Myself, Achal Sharma from Shivaji Rao S. Jonle College of Pharmacy, Asangao, studying in SY BPHARM under the guidance of Professor Dr. Nitin C. Mohire sir. That's our principal. Today I'm gonna represent medicinal synthesis reactions and the uses of thiazole, pyridine and quinoline. So here we will proceed with the thiazole. It is a pale yellow colored liquid having a boiling point of 116 to 118 degrees Celsius. Thiazole was first described by Hanses and Weber in 1887. The partially reduced thiazoles are thiazolines and completely reduced thiazole is called as thiazolidine. So here is the structure of an thiazole. Then is the chemical synthesis of a thiazole. So first is the treatment of N-N-diformyl aminomethyl aryl ketone with phosphorus pentasulfide and triethylamine in chloroform gives 5-aryl thiazole. So here's the reaction which represents the synthesis of an thiazole. Then is the Hansen synthesis. It is a condensation reaction between alpha halo carbonyl compound with an appropriate thioamide or thiourea. The thioamide can be obtained by reacting phosphorus pentasulfide and formamide at room temperature. So is the reactions which shows the Hansen synthesis of an thiazole. Gabriel synthesis. The alpha acyl aminoketones react with the phosphorus pentasulfide to give 2 or 5 or 2,5 disubstituted thiazole. Then is the chemical reactions of thiazole, which include first is a protonation. Thiazole gets easily protonated at N3 positions due to lone pair of electron available with nitrogen. In thiazole ring, the position 2 is most electron deficient position, 4 almost neutral and the position 5 is slightly electron rich. Then is the deprotonation at a C2. The organolithium compound cause removal of proton at C2, then reacts with a range of electrophiles such as aldehyde, alkyl halide and a ketone. So here's the reaction which represents the deprotonation at C2. Then is the N-alkylation. Thiazoles reacts with alkyl halides to form thiazoline, etc. This cation is resonance stabilized with the positive charge residing mostly on the sulfur atom. Then is the medicinal uses of a thiazole. Vitamin thiamine, which is also known as B1 vitamin, contains both pyrimidine and a thiazole ring system. It is also an important scaffold in antibacterial, antifungal, antidiabetic, anti-cancer and anti-convulsant drug design. This include nitazoxanide, thiabendazole, fentazole, fentiazic. Then is the sulfethazole, which is also known as an antiviral, antihelminthic and immunomodulator, NSAID. Then is antibacterial, H2 receptor blocker, etc. This type of drugs. Penicillin contains reduced thiazole ring, which is also known as an thiazolidine. Then is the pyridine. It is a colorless liquid with a boiling point of 115 degrees Celsius. It has a fishy odor. It was first obtained from bone oil in 1849 and coal tar. The lone pair on N atom is located in an sp2 hybridized orbital and is not involved to maintain aromaticity. The lone pair of electron is available for protonation and the basicity of pyridine. Electron donating substituents at 2 and 6 position enhances the basicity. So here's the structure of an pyridine. Then is the chemical synthesis of pyridine. Pyridine is synthesized by reacting acetaldehyde with formaldehyde and ammonia. Then is the Hansen synthesis. It is a condensation reaction between an aldehyde, 2 equivalent of 1,3-dicarbonyl compound and ammonia. Then is the Gaureschi-Thorpe synthesis. 2 molecules of aldehyde condenses with the ketoester to give substituted pyridine. Then is the chemical reaction of an pyridine. The electronegative nitrogen in the pyridine ring make the pyridine molecule relatively electron deficient. It does not undergo electrophilic substitution readily, more prone to nucleophilic substitution at position 2 and 4 and metallation of the ring by strong organometallic bases. Like tertiary amine, pyridine undergo N-protonation and undergo oxidation to form an N oxide. Then is the N-protonation. The lone pair of electron on the nitrogen atom in pyridine is available for extra bonding. When a pyridine reacts with acidic metallic ions or aryl or sulfonyl anhydrates, it forms quaternary salts. Pyridine form crystalline hygroscopic salts with most protic acid. Then is the electrophilic substitution. Benzene readily undergoes electrophilic substitution reaction. In pyridine, an electronegative N atoms creates pi electron deficiency at each C atom and deactivates the ring towards electrophiles. So the protonation of an N atom further deactivates the ring. Hence, pyridine undergo electrophilic substitution with extreme difficulty and only under extreme reaction. Halogenation and nitration. So, under electrophilic substitution, there is an halogenation reaction and nitration reaction take place with pyridine. For example, pyridines react with the bromine in presence of 130 degrees Celsius and 66% oleum. So the product will be 3-bromopyridine. Accordingly, we have two more reaction with the nitric acid and sulfuric acid in different temperatures. Then is the nucleophilic substitution reaction. Electrophilic substitution is a characteristic reaction of the benzene with nucleophilic substitution is the characteristic of pyridine. So the nucleophilic take place at C2 and C4 position, as you can see in a reaction. Then is the alkylation under nucleophilic substitution and arylation. Pyridine reacts with alkyl or aryl lithiums to give a dihydropyridine intermediate, which then gets converted into substituted pyridine. This is the reaction that you can see that alkyl group is attaching in a pyridine ring. Then is the medicinal uses of pyridine. It is present as a core skeleton in a pyridine, tripylinamine, mipyramine, then nicacin, pyridoxine, isoniazid, etc., which is known as an antibacterial, antihistaminic, vitamin, anti-TB, etc. Also used as a solvent in the pharmaceutical industries. It is also used as an anti-cancer in a drug called as a chrysotinic. It is also used as antifungal agent in the medication of a drug, i.e. bengazole A. Then is the quinoline. Quinoline or a 1-azanaphthalene is a colorless liquid with a sweetish odor and has a high boiling point of 237 degrees Celsius. It was first isolated in 1834 from coal tar. Quinoline is weakly acidic compound. Electron releasing substituents at the 2 and 4 positions of quinoline increase the basicity. The electrophilic attack will take place at electron with C2 and C4 position. Due to presence of electronegative N atom close to C2, the C2 and C4 positions are electron deficient. Hence, nucleophilic attack take places preferentially at the C2 and C4 position. So here is the double aromatic ring of quinoline. Then is the chemical synthesis of quinoline. Ssjcop synthesis when aniline concentrated sulfuric acid, glycerol and mild oxidizing agents are heated together, quinoline is formed. The reactions begin when glycerol is first dehydrated by concentrated sulfuric acid to acrolein. Aniline is then added, begins to its produce 1,2-dihydroquinoline. The 1,2-dihydroquinoline is further oxidized to give quinoline. Aniline adds to acrolein through Michael additions to give aniline. Substituted aniline give quinoline derivative in which substituents appear in benzene green portion. So here's the reaction which represents the synthesis, Ssjcop synthesis of quinoline. Then is the Friedlander synthesis when O-aminobenzaldehyde or O-aminoacetophenone condenses with an aldehyde or a ketone in alcoholic sodium hydroxide solution, it yields quinoline. Two substituted quinoline derivatives are usually prepared by this method. Then is the P-Fitzinger synthesis. In this method, acetine in the presence of a base is converted to isotoic acid, which is condensed with a ketone to give quinoline for carboxylic. The carboxylic acid group can be removed by pyrolysis with calcium oxide to give substituted quinolines. That is the chemical reactions of the quinoline. For that, we'll see some chemical nature of an quinoline. It is a weak base. The electron-rich N atom of quinoline is the main site for attack by electrophile. Then this N atom deactivates the ring towards electrophile attack. Hence, electrophile substitution on quinoline rings requires vigorous reactionary condition. The electron-rich N atom makes the pyridine ring more pi electron deficient. Hence, electrophile attack occurs at the benzo rather than more resistant hetero rings, while nucleophile attack occurs at hetero ring rather than benzo ring. Addition to nitrogen, the lone pair of electron on the atom is available for extra bonding. When quinoline reacts with acid, metallic ions or acyl, sulfonyl and hydride, it forms quaternary salts. Like quinoline is reacting with the HCl, aluminium chloride, you can see that there is a formation of quaternary salts as a result or as a product. Electrophilic substitution preferably occurs at a position 5 and 8. Here the quinoline is reacting with the sulfuric acid or a nitric acid or a bromine or aluminium chloride or a sulfate group in the presence of some temperature. So we'll get two compound or two products as a result. First will be at a 5 position and second will be at the 8 position. That is the reduction quinoline. It's reduced to 2,3,4 tetrahydroquinoline using catalytic hydrogenation in methanol. Lithium in liquid ammonia can produce 1,4 dihydroquinoline under certain conditions. In acidic medium, the benzene ring can be selectively reduced. So here's the reaction which represents this reduction reaction of quinoline. Then is the medicinal uses of quinoline. It is a core component in the structure of an chloroquine, papaverine, quinapril, singular, hydroxychloroquine, narcotin, amitin, dimethysoquine, which is also known as an anti-malarial, smooth muscle relaxing, anti-hypertensive, anti-asthmatic, anti-malarial, depressant. Then is the vomiting inducer, anesthetic, etc. So that's it, and here are some links which I have referred to make this PPT. So under the acknowledgement of our President Dr. Shivaji Rao S. Junle Sir, Dr. Geeta Khare ma'am as our secretary, and the principal sir, that is Dr. Nitin C. Mohire sir. Thank you for watching this video. Hope you like this video. For more informative videos, subscribe to our YouTube channel. Thank you.